Hi Chem Peeps. In this video we're going to talk about Raoult's law, which goes into mole fractions and partial pressure of our solvent over a solution. So on the left side of my screen here you can see I have some facts about Raoult's law that we're going to discuss, as well as the formula that we're going to use in this problem set. So first of all, the vapor pressure is the force that is exerted by a solvent's vapor upon the surface of the solvent. Additional non-volatile solutes, in other words, when we have a solution, something's dissolved in that solvent, will reduce the amount of molecules that can escape the liquid to become a vapor. So when you have the pure substance, its vapor pressure above its surface is going to be greater than when you take that same liquid as a solvent in a solution and you dissolve a solute in it. Less of that solvent is going to become a vapor. So overall, it lowers the vapor pressure. So Raoult's law quantifies the extent to which a non-volatile solute will lower the pressure. So you can see that we have a formula here. The partial pressure is going to equal the mole fraction times the pressure of the pure solvent. Okay, so I should have a T there. So if we look here, this first substance that we're finding, P of A, is the partial pressure of the solvent. This X of A is the mole fraction of that solvent, and then the P prime of A is going to be the vapor pressure of the pure solvent. So let's look at the problem that we have on the right side of our screen. It says calculate the vapor pressure of a solution when 235 grams of sugar are added to 650 milliliters of water at 40 degrees Celsius. The vapor pressure of the water at 40 degrees Celsius is 55 millimeters of mercury. In other words, this is when it's pure. So if this is the pure substance, this is going to be our P of A prime that we're going to use in our problem. So the first thing that we need to do is that we need to figure out some mole fractions here. So the first thing I'm going to do is find the mole fraction of the sugar, and that is going to be the 235 grams that they give us of the sugar divided by its molar mass off the periodic table, which is 342 grams per mole. Real quick, I'm going to add up 12 carbons, 22 hydrogens, and 11 oxygens on the periodic table, and I'm going to get a mole fraction of 0.687, and that's going to be of sugar. Okay, then I'm going to find the mole fraction of water, and water is going to be 650 grams that they gave us, divided by its molar mass off the table, which is 18, that's just a 1 there, grams per mole. And that's going to come out to be 36.11 for water. Now, actually, I mislabeled here. These are just the moles of each. I'm sorry. I went and incorrectly labeled that at the beginning. Okay, now we're going to find the mole fraction. The mole fraction of water is going to be the moles of the water over the moles of the solution. So the moles of the water was the 36.11 moles of water. We're going to divide it by the solution. So we're going to have to add the solute and the solvent here. And there we go. So the mole fraction of water is going to come out to be 0.9813, and there's no label on that. Okay, so that's not the final. They want to know the vapor pressure of the solution. So the pressure of the water is now going to be the mole fraction of that water times the partial pressure of the water. So if we plug in what we found, we have 0.9813 for the water, times what it is when it's pure, which is 55 millimeters of mercury. And so our final answer is going to come out to be 53. Oops. No, doesn't want to write. Let's write it over here. Let's just go this way. It's going to be 53.97 millimeters of mercury. And that makes sense because pure water is 55. And if we dissolve some sugar in it, less of the water is going to be able to vaporize from its solution. Therefore, it's going to lower the vapor pressure. And so that makes sense. Okay, so this is an explanation of Raoult's law, as well as a sample problem. There will be more videos with solution properties, both formulas and concepts, on TikTok and YouTube at Chem's Chem Chats. I'll see you on the next video.